We know about a black hole that it is a region in the universe where the force of gravity is so strong that it can pull anything that comes near it inside. It is said that even light cannot escape from its grasp. For a long time, a black hole has been seen as a cosmic monster in the universe that devours everything that comes close to it. But how true are the accusations against black holes? What if I tell you that these black holes can not only destroy star systems, but also create entire solar systems? Scientists have found evidence that suggests that black holes might not be like space monsters, but perhaps they possess the ability to give birth to new universes. But how? To find out, keep watching the video till the end. Hello friends, I am welcoming you to Universe Tour. In this video, the first question that comes to mind is whether a black hole is truly a black hole or if it is formed like a hole in the universe. Now, if you ask this question to a mathematician, astronomer, or scientist, their answers will probably be somewhat similar. However, their approaches will be quite different. This is because the physics inside a black hole works very differently from our laws of physics. According to Albert Einstein, there is so much gravity within this object that it bends space itself. Now, how does it possess so much gravitational power? Almost all of us know that the formation of a black hole happens due to the gravitational collapse of a star. Scientists believe this as well. All the stars in this world whose mass is more than 2 to 5 times that of our Sun have the potential to be converted into a black hole. Despite being born from such massive stars, their size is very small. Now, if we assume that for some reason our Sun were to be converted into a black hole, its radius would be only about 3 kilometers. Of course, our Sun is not going to become a black hole. But I want to tell you that perhaps you might understand. The truth is that any object in the universe can be converted into a black hole, but for that, the object would need to be compressed very forcefully. If you're trying to compress the Earth and turn it into a black hole, you would need to compress it so intensely that its radius would only be about 0.89 centimeters, equivalent to a grain of rice. You can understand black holes in 2 ways. One through the theory of general relativity, and the other through the theory of quantum mechanics. According to the theory of general relativity, the entire outer surface of a black hole acts as a boundary that prevents light and matter from escaping in any way. This boundary is called the event horizon. It's the point beyond which the gravitational force of the black hole becomes so strong that nothing can escape it. Nothing can return from there. Hence, it's also known as the point of no return. If somehow you were to venture directly into the middle of a black hole, you would eventually reach a singularity where space-time becomes infinitely warped and our known physics breaks down completely. A black hole doesn't have a surface. The event horizon is just like a threshold, where the journey into a black hole begins. We don't yet know what lies at the end of a black hole. This question troubles every physicist in the world. What will we experience? If by mistake we go inside a black hole and someone outside tries to see us, how will we appear to them? One thing is certain: when you cross the event horizon, your reality will be completely altered. According to scientists, as you cross the event horizon, you won't even realize it. You'll feel as if you're continuously falling down a steep slope. You won't experience any pressure on your body. However, this fact holds true only in the case of large black holes. Crossing the event horizon of a small black hole will result in your death in a painfully stretched manner, like noodles. On the other hand, entering a larger black hole will not lead to your immediate destruction. Gradually, as you fly towards the singularity within a big black hole, an observer from a distance would perceive you vanishing as you cross the event horizon. According to Stephen Hawking, going inside a black hole would make you completely disappear from the universe. But this creates a profound paradox. One fundamental law of physics asserts that information can never be destroyed. However, going into a black hole seems to violate this law. Whatever enters a black hole seems to cease to exist completely. This gives rise to the black hole information paradox. Near the event horizon of a black hole, there exists a virtual particle known as Hawking radiation. This radiation is thought to emerge from the black hole and gradually decrease its mass. It's possible that information might exit through this radiation. Some scientists have found another way to understand this paradox. The capacity of a non-charged black hole can be measured only in terms of its mass. When an object enters a black hole, there's no noticeable change on its outer part, except for its mass. However, this perspective changes when considering its mass. Scientists in the scientific community refer to this expression. My point is that for all non-charged and non-spinning black holes with the same mass, no difference can be discerned. Even if an object's information is stored inside a black hole, the radiation coming out of it doesn't show any change. Scientists who study string theory suggest that black holes are made entirely of quantum strings, which vibrate according to their quantum rules. I understand that this might be confusing, but try to imagine a black hole as an object filled with many smaller objects, like balls of yarn. According to this theory, there is no similarity between the insides of black holes. Even space-time doesn't exist beyond the event horizon. When you fall into a black hole, you slightly alter the vibrations of those yarn balls, which in turn slightly alter the radiation emerging from it. This complicated theory has shown that information is not destroyed inside a black hole. It rather transforms and comes out as radiation. When viewed from the perspective of Einstein's theory of relativity, black holes seem to pose many difficulties. However, when viewed from the perspective of string theory, these issues are resolved. On January 2, 2022, the Hubble Space Telescope surprised scientists with a significant discovery related to black holes. They found that radiation emitted from a black hole directly affects the process of star formation. While observing the galaxy AENSE 210, Hubble detected a radiation flow moving towards a gas cocoon. This radiation was coming from where a black hole was present. The radiation was impacting the gas compression process, which leads to star formation. This galaxy is only about 30 million light-years away, allowing Hubble to provide Earth scientists with better images for studying early star formation processes. Until now, it was believed that black holes only destroy things, but this new finding suggests that perhaps the birth of countless galaxies might be attributed to black holes. What do you think? Could new stars indeed be born due to black holes? That's all for this video. See you in my next one. Goodbye.